Welcome to the full solutions to the practice questions to the first video on vectors scalar products. For the first question today, we are going to determine the angle between these two vectors. Whenever we're given components of two vectors, the most efficient way, or one of the most efficient ways of calculating the angle between them is using dot products. So the dot product for vector A and B is equal to the magnitude of A times the magnitude of B times the cosine of theta, and that theta angle is the angle between them. To find the dot product using the components, we do A dot B is equal to, and we are going to multiply their x components together, so we'll do these first, and then we'll do y components, and then we'll do the z components, and we'll add them together. So we will get 3 times 4 plus negative 1 times 2 plus 4 times negative 1. That is 12 minus 2 minus 4, and that is equal to 6. So that's the first part. Then we can find then we have found this to equal to 6, and then we need to find the magnitudes of A and B. So the magnitude of A is equal to the square root of its x component plus the y component plus the z component. And that will equal to root of 9 plus 1 plus 16. And that is equal to root of 26. The magnitude of B is going to equal to root of its x squared, which is 4, the y squared, which is 2 squared, and the z component squared, which is negative 1 squared. This will be root 16 plus 4 plus 1, which is root 21. Once I have this, I know that 6 is equal to root 26 multiplied by root 21 cosine of theta. I am going to divide both sides by root 26, root 21 to cancel these out. So root 26, root 21. And I get that cosine of theta is equal to 0.256776, and the number continues. So theta will equal to the inverse cosine of that value. And when we do the calculation, we'll end up getting theta is approximately 75.1 degrees. And that is the angle between vectors A and B. In this question, we're asked to determine the value of the z for which vector u and vector v are parallel and perpendicular. There are multiple ways of going about this, but if we were to use the dot product to do it, then when the two vectors are parallel, the angle between them is either 0 or 180 degrees, and when they're perpendicular, their angle is 90 degrees. For both situations, we will need the dot product of the two vectors. So let's put that, let's write that down first. So I'm going to take the x components, multiply them by each other, y components, and the z components. For the x components, I'm going to get negative 1 multiplied by 3 plus 4 times negative 12 plus z times negative 3. This will give me negative 3 minus 48 minus 3z. This will end up being negative 51 minus 3z, and that's as simplified as I can get it. I also know that, so I'm going to actually write this like this, and I also know that u dot v is also equal to u magnitude of u times magnitude of v times the cosine of the angle between them. So let's find the magnitudes, and I'll do this using blue. So the magnitude of u is equal to the root of the x component squared plus the y component squared plus the z component squared. And when we do this, we get 1 plus 16 plus z squared, and that's equal to root of 17 plus z squared. The magnitude of v is equal to root of its x component squared plus the y component squared plus the z component squared. And when I do this, I get 9 plus 144 plus 9. This will end up giving me root of 162, and this can be simplified as root 81 multiplied by root 2, which is 9 root 2. Now, if you wanted to use the dot product to solve part A, then u dot v, we know that that's negative 51 minus 3z, is equal to the magnitude of u, which is root 17 plus z squared, multiplied by the magnitude of v, which is 9 root 2, put this in bracket, and cosine of theta, so cosine of 0 is equal to 1, and cosine of 180 is equal to negative 1, so I'll just choose 1 for now. And then what you would have to do is you would actually have to solve for z, but that's a little bit challenging because you got z here and you got z here. It's not the worst. You can actually square both sides. So if you square this side, you will get you would have to do a binomial expansion. You would have to then square this side and then set them equal to each other and then find your final value for z. But there's a much easier way. So let's use the easier method actually to show you what the answer will be, and we'll come back and check it just to make sure that it's correct. So basically, to see if two vectors are parallel, all we have to do is look at it in terms of v is equal to some scalar multiplication of vector u. So vector v here is 3, negative 12, negative 3, and that equals to k multiplied by negative 1 for z, that's vector u. And we can see that for the x components, 3 is equal to negative k. For the y component, negative 12 is equal to 4k. And for the z component, negative 3 is equal to z times k. In the first two situations, we'll see that k is equal to negative 3. For the second situation, k is equal to negative 3. So for the third situation, also k should equal to negative 3. And therefore, negative 3 is equal to negative 3z. Divide both sides by negative 3. And we get z is equal to 1. Okay, now that we have this, let's go back and see if z is equal to 1 if our equation actually holds. So in the first case here, we got negative 51 minus 3 times 1, and that will give us negative 54. And on the right-hand side, we got 17 plus 1 squared times 9 times square root of 2. And cosine of theta is either 1 or negative 1. This is if theta is equal to 0. This is if theta is equal to 180. So let's keep it as 1 for now. And this is going to equal to root 18 times 9 times 2. Actually, I'm going to say 1 or negative 1. So this is going to be 1 or negative 1. This is going to be negative 54. Root 18 times root 2 is root 36 times 9 times 1 or negative 1. And finally, negative 54 is equal to root 36 is 6 times 9 times 1 or -1, and -54 is equal to 6 times 9, which is 54 times, in this case, can't be 1, it has to be -1. So therefore, theta here is equal to 180 degrees. Okay, so we know that part now. So basically, we could have actually used we could have actually square both sides and solve for z, but it would have been a very challenging method because we would have to do it for theta is equal to 1 and theta is equal to -1 to kind of see which one of those will give us the proper answer. This method over here is much easier to use when we want to figure out the value of something when vectors are actually parallel. When vectors are perpendicular, it's a lot easier to use the dot product. So we already know what the dot product of the two vectors are. So for part B, we know that u dot v is equal to -51 minus 3z. That doesn't change, that's the value, or that's the expression we got here. But for the second part, we know that if the angle between them is 90 degrees, then as we discussed before, we get magnitude of u times magnitude of v times cosine of 90, and cosine of 90 is 0. So then u dot v should equal to 0. We know u dot v is this, so -51 minus 3z is equal to 0. We're going to rearrange by adding 51 to both sides, and we get -3z is equal to 51. Divide both sides by 3, or -3 in this case, and z will end up being -17, and that is our final answer for this case, and z is equal to 1 for the first part. For the last question of this video, we have Robo who exerts a force F1 on a box and moves it for displacement delta D. We want to determine the work done and the angle between the force and the displacement. Well, we know that the work done is equal to the vector force dotted by the displacement. And we have the components of force and displacement, so we can use them. So we are going to take the x components, multiply them, y components, multiply them, and z components, multiply them, and get their sum. So we get 30 multiplied by -5 plus 40 times 4 plus -10 times -1. This is going to equal to -150 plus 160 plus 10. Now the first two, -150 plus 160 is 10, and plus 10 will give me 20. And since my force unit here is Newton, and let's say displacement is meters, I forgot to include the unit, my final unit here is going to be in joules. And work has no direction. Whenever you get a dot product of two vectors, you always get a scalar value with no direction. Now we want to determine the angle between the force and the displacement. Well, what we have to do is use the other property of the dot product. So we know that work is equal to F dot delta D, and we know that that's also equal to the magnitude of the force multiplied by the displacement magnitude multiplied by the cosine of the angle between them. We already have this calculated. This is equal to 20. We need to calculate a few things on the side here. the magnitude of force is equal to the root of the x component squared plus the y component squared plus the z component squared. And that is equal to 900 plus 1600 plus 100, which will end up being a root of 2600, which can be simplified as root of 100 by 26, and that's 10 root 26. The magnitude of the displacement vector is going to be root of, and I am going to do -5 squared plus 4 squared plus -1 squared. So this is going to be root of 25 plus 16 plus 1, and this is going to be root of 42. So once I have this, I can come back and plug those values in here. So I have this and I have this value now. So I can say the magnitude of the force is 10 root 26, and the magnitude of the displacement is root 42, and I'm trying to find the angle there. I'm going to divide both sides by 10 root 26 root 42, so 10 root 26 root 42. And by doing this, we get that cosine of theta is equal to 0.0605. The number continues. I will use the exact value on my calculator, but I will just write it to 3 significant figures here. Theta is going to be the inverse cosine of that value, and when we do that, we get 86.5 degrees as our final answer, and that is the angle between the two vectors, the force and the displacement vector. I hope that this video was helpful in giving you some idea about how the questions work in basic dot product questions, and thank you for watching.